Students, whatever homework is given to you, you have to submit it on the very next day between 8 am to 1 pm to the given WhatsApp number, and it is compulsory to submit your homework as your attendance will be marked on the basis of your submission.
Good morning, children. Today we are going to start a new chapter, that's arithmetic progression. Okay. Previously we have completed 3 chapters already, and then you do the test of that also. Now today we are going to see about arithmetic progression. You know that in our nature we have seen so many patterns like petals of a sunflower and the folds of a honeycomb, the grains on a maize cob, etc. In same way, here also in day-to-day life, we are going to see a pattern of numbers. For example, I have written some patterns of numbers here, series of numbers, a sequence of numbers. I have written here that 100, 150, 200, 10, 7, 4, 1, 2, 6, 18, 54, 16, 4, 1, 1 by 4. So can you say its fourth number, what you will be the next number of this series, this sequence. And 10, 7, 4, 1, you can say what is the next number by looking at this pattern, because it is following a particular rule and regulation for continuation of this series. 100, 150, 200. This year you know that 100, 150. What is the difference in between that? Plus 50. We are adding 150 over here. So you are going to get 150. Next 50 when you are adding, you are going to get 200. So obviously you can find out the next number here. What is the number? 250, etc. Like that way it will be continuously goes on. This pattern follows a particular method. What is that? It's adding by some fixed number. Next 10, 7, 4, 1. Here also you can see some following some pattern. What is the pattern here? That here subtraction of 3. So right, 10 minus 3 is 7, 7 minus 3 is 4, 4 minus 3 is 1, etc. like that. Third one is that 2, 6, 18, 54, etc. Here you know that we have multiplied 2 to 6, then 2 3s are 6, 6 to 3, then you multiply, then you get 18, 18 3s are 54. That means by adding with a fixed number, multiplying with a fixed number, you are going to get a series of these numbers. In this case, 16, 4, 1, 1 by 4. Here you can see that the first number is 16, second number is 4. That means dividing by 4, you are going to get 4. Next, this 4 is divided by 4, then you are going to plus 1. Next, you divided by 4, then you are going to plus 1 by 4. That means this series of numbers, we are seeing some patterns. By adding a fixed number, by subtracting a fixed number, multiplying a fixed number, by dividing a fixed number, you are going to get a series of numbers like this one. Got it? And this pattern of numbers we are not going to discuss. Here we are going to discuss what pattern of numbers. That means when you are adding a fixed number to the previous number, so you are going to get the succeeding number. That means if you want to get 150, you have to add 100 plus 50. Okay? Same way, 150 plus 50, you are going to get 200. This fixed number may be positive, negative or 0. And that type of pattern of numbers only, that type of sequence of numbers only you are going to constitute for arithmetic progression. That means it is a series of numbers. Progression means series. It's a series of numbers, but that pattern should follow. How that pattern should be? Every succeeding number should get by adding a fixed number to the previous number. That addition, that means adding number, can be positive, negative, 0. That means in these two cases, 100 plus 150, that means for getting 150, you are adding 100 with the 50. That means here the difference, that means that the fixed number is plus 50. But in this case, 10 and 7, here that fixed number is minus 3, because we have to get 7 number. By adding minus 3 only we are going to get 7. That means here the number constant number which is at minus 3. So this type of series we are going to see in this chapter, that is known by the name arithmetic progression. That means that type of series, that type of progression, that type of sequence, where the succeeding number is going to be obtained by adding to the previous number, fixed number to the previous number, and that way that adding that number will be either will be negative, yeah will be positive, yeah it will be 0. And here in a series there are written so many numbers. So these each number we can call by the name term of this series. That means this is the first term, second term, third term, fourth term, like that. Now we understood that what is arithmetic progression. Now look at some of the examples here. 1, 2, 3, 4, etc. 100, 70, 40, 100, etc. 10, etc. Minus 3, minus 2, minus 1, 0. 3, 3, 3, etc. These all are the series. These are our pattern of numbers which follows a certain sequence. Here, look at the first one. Second number, that means 2 is getting by adding 1 to the previous term. 3 is getting by adding 2 plus 1. 4 is getting by adding 3 plus 1. Same way, here you can see that 100, 70, 40, 10. In each term, that means getting by 30 is less than. Is it right? 100 minus 30 is 70, 70 minus 30 is 40, 40 minus 30 is 10, etc. And in this case, minus 3 minus each term is obtained by adding 1 to the term preceding to it. Is it right? Minus 3 plus 1 is equal to minus 2. Minus 2 plus 1 is equal to minus 1. Minus 1 plus 1 is equal to 0. Now, next one, 3, 3, 3, 3. Here also, when you are adding a fixed number, that is 0. Is it right? 3 plus 0 is 3. 3 plus 0 is 3. 3 plus 3 is 0 is 3. Now, next one, minus 1.0, minus 1.5, minus 2.0. Here you are adding plus minus 0.5. Is it right? Minus 1, minus 0.5 is coming, minus 1.5. Minus 1.5 plus minus 0.5 is coming, minus 2.0, etc. So this series has this pattern. Have you seen any similarities? Yes. It's a list of numbers. Is it right? It's a list of numbers in which each term is obtained by adding a fixed number to the preceding term. Is it right? That means here for getting the 2 number, so we have to add 1 plus 1. Is it right? We have to get 70, then you have to add minus 30. Is it right? Like that. So like this way, this continuously moves on. That means arithmetic progression. These all are the list of arithmetic progression. Why? Because it is a list of numbers in which each term is obtained by adding a fixed term to the number to the preceding term except the first term. That means what is the difference of these two? 1. This difference is 1. This difference is also 1. Same way here, 70 minus 100 is minus 30. Here is minus 30. This one also minus 30. And this both minus 3 and minus 2. Its difference is that 1. Here also 1. Like this way this goes on. Here the difference between 3 and 3 is 0. Difference between 3 and 3 is 0. That means successive terms. Difference, that means the fixed number, that is common only. Is it right? So we can say that these all are the arithmetic examples of arithmetic progression. That means it is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. That means first term as it is, it will be there. For getting the succeeding numbers, we have to add some fixed number to that. That fixed number is called by the name common difference, that is denoted by small d. Okay, common difference. That means which is a number we are going to add it for this getting the series of numbers. This pattern of numbers. This common difference we call by the name d, and short form we can write arithmetic progression as AP. Now we understood that. What do you mean by arithmetic progression? It's a list of numbers in which each term is obtained. I told you that these numbers 1, 2, 3, 4. This is the first term, the second term. That means numbers which are in this list of numbers we will call by the name term of the numbers. That means the first term, second term, third term, fourth term, etc. Here also this is first term, second term, third term, fourth term. Now the fixed number which is adding, that will be called by the name common difference. Now, one more thing you want to note here that the fixed number can be either positive, yeah, negative, yeah, 0. In this case, you have seen that here common difference is 1. Here common difference is minus 30. Here common difference is 1. Here common difference is 0. Here common difference is that minus 0.5. So here we can see that common difference can be either positive, yeah, negative and 0. Okay. Both may you want to clear that what is meant by arithmetic progression, what do you mean by common difference. Now let us find out the general form of the arithmetic progression. Now for finding out the general form of an AP, let us denote the terms of an AP. So first term we have denoted as A1, second term as A2, third term is A3, A4, etc. like that. Okay? Now next one is that you know that if it is an AP, the common difference should be same for the succeeding numbers. That means A2 minus A1, A3 minus A2, A4 minus A3 is equal to the last term. That means the last term up to where it will be there? AN minus 1. That all should have the same common difference. Common difference already I mentioned you that what is meant by common difference. Okay. Then we can say that this follows an AP. This pattern follows an AP. Now how can you write this AP in general form? As you denote that first term we are denoting by A1. But general form we are denoting that A1 by E. Is it right? Second term is A2. How you are going to get A2? Because you know that A2 minus A1 is equal to D. Is it right? But is A2 minus A1 is equal to D. So for getting A2, what you should do that? A1 plus D. Is it right? When you are taken D this side, yeah, that side you are taken A1, so it will come A2 is equal to what you will get? A1 plus D. So instead of this first term, I have written A only. Okay. Therefore, what is the second term now will come? It will come as A plus B. Now, for third term for finding out the third term, what we will get to find out A3. So we know that A3 minus A2 is also is equal to what? D. But what you got that A2 is equal to A plus D. Now substitute here A3 minus A plus D is equal to D. That means A3 will be is equal to A plus 2D. When you are taking that side, this D and D will be, total will be 2D, because minus totally it will come plus that side. So A plus D and D plus A. That means A plus 2D. So second term, third term will be A plus 2D. Subsequently, the remaining terms you can find out like this way. A plus 3D, etc. A plus 4D, etc. That means general form of an AP you can say like this way. General form of an AP is A plus D, A plus 2D, A plus 3D, etc. How you just got, you already understood that. First term I noted by A1 as A. For getting second term, you know that A2 minus A1 is equal to D. And by substituting A1 as A, you got that A2 is equal to A plus D. Same way for getting A3. A3 means, you know that A3 minus A2 is also is equal to common difference is same. So for writing here A2, the value of A2 as A plus D, you are going to get A3 is equal to A plus 2D. Same way, A4 is equal to, the next fourth term will be A plus 2D, fourth term will be A plus 3D, fifth term will be A plus 4D, like that it will be continuously goes on. So this is the general form of an AP. Now clear for you children? Now two terms you have to find, you have to learn now. What is that? Finite AP and infinite AP. What do you mean by finite AP? Suppose if I have written one series like this way, 1, 2, 3, 4, 5 up to 10. So this is an arithmetic progression only, but here first term is also there, last term is also there. That means number of terms are finite. In this AP, the terms are finite, therefore we will call by the name finite AP. Otherwise, if I have written one progression like this way, 100, 50, 0, etc., etc., like this way. That means there is no last term here. So that type of progression we will call by the name infinite AP. So finite AP and infinite AP. So here we have seen the generally the introduction. That means what is the arithmetic progression means. And what is common difference? What is the definition of arithmetic progression? What is the definition of common difference? I already mentioned you that common difference can be positive, negative or a zero. And how can you denote the terms of an AP? Like this way, or how can you write it in general form? Okay? And finite and infinite AP. Now let us look at some of the sums in the exercise. Look at the exercise 5.1. Question number 1 you can do yourself because it is a practical applications of arithmetic progression only. You have to check that whether that is an arithmetic progression or not by giving some statements are given. That you can do yourself. Second one, write the first 4 terms of the AP. First term is given and common difference is given. That means question number 2, second question I wrote here. A is given that -2, the common difference. That means which number should be added to get the fixed number. That is already given that 0. So here you know that there is no change because the difference is 0. The series of numbers will be -2, -2, -2, -2. Is it right? Second question, that means I am taking for fifth question. That means A is equal to -1.25. D is equal to -0.25. That means for getting the successive numbers, what should be added? This common difference you should be added. For example, -1.25 is the first term. So when you are adding -0.25 with this -1.25, you are going to get -1.50. Then -1.50 plus -0.25, you get -1.75. -1.75 plus -0.25 will be -2. 4 times only asked, therefore I written only 4 times. The remaining you can do yourself because it is a very simple sum only. Third question is that some APs are given. It's already given that it's an AP. So you know that for writing an AP, what are the things you needed? First term you needed and the common difference you needed. So here for the following APs, write the first term and the common difference. Here you know that 3, 1, -1, -3, etc. One question I taken here that. So here first term you already know that what is the first term? 3 is the first term. Or for getting the common difference, what you will do that? You will just A2 minus A1. You know that. A2 minus A1 you do. Yeah, A3 minus A2 you do. Yeah, A4 minus A3. So I have taken that A2 minus A1. That means 1 minus 3. So what is the answer you are going to get? -2. Same time, if you are doing this one, -1, -1, then also you will get the same answer as -2 only. Okay, clear for you children now? That means when you are taking the common difference, you have to just take the successive terms difference only. Now that question is also you can do question number 3. That also you can find out the first term and the common difference. Simple sums. Now fourth question it is asked that which of the following are APs? Some pattern of numbers are given that you have to check that whether it is an AP or not. For that purpose I have taken some of the sums here. 2, 5/2, 3, 7/2. So what you should check that the common difference is same or not. That means you have to check here that A2 minus A1, what is that? Then you take that A3 minus A2. Then you will take that A4 minus A3. Are they same or not? So first one will be 5/2 minus 2. What is 5/2 minus 2? It will come LCM you take. So 5 minus 4/2. 5 minus 4, 2 2s are 4. 5 minus 4, it is 1. So you get that which is equal to 1/2. Now second one is that for 3 minus 5/2. So here we get 3 2s are 6. 6 minus 5/2. Again you are going to get 1/2. Is it right? But next one 7/2 minus 3. 7/2 minus 3. Again 7/2 minus 6/2. So again you are going to get 1/2. That means it follows that AP. Why? Because common difference is same. A2 minus A1 and A3 minus A2, A4 minus A2, that is A4 minus A3 all coming as a same. Next one 3 plus root 2, 3 plus 2 root 2 etc. Here also we have to take A2 minus A1. A2 minus A1 will be there 3 plus root 2 minus 3. 3 plus root 2 minus 3. What's the answer for that? 3 plus root 2 minus 3 is equal to, you will get that root 2. What is A3 minus A2? 3 plus 2 root 2 minus of 3 plus root 2. That means 3 plus 2 root 2 minus 3 minus root 2. So here they are getting 3 root 2 and 3 and minus 3 cancel. 2 root 2 minus root 2, you are going to get the answer root 2. That means in the first two terms common difference is 2. Second two terms there are also common difference 2. That means what we can say that this also follows an AP. Clear for you? So this both forms a clear and AB. Now next question, root 2, root 8, root 18, root 32. Root 2 is the first step. So A2 minus A1 means root 8 minus root 2. Root 8 you can write it as that 2 root 2. The 2 root 2 minus root 2 it is coming how much? Root 2. Why root 8 is 2 root 2? Because 8 4 2s are 8. 4 square root is 2 like that. Second term is that A3 minus, second difference, A3 minus A2. That means root 18 minus root 8. Root 18 you can write that 3 root 2. So 3 root 2 minus 2 root 2. Here also you are going to get the answer as root 2. That means in this case also it follows an AB. Now one more example, one more question I want to solve here in this class. That is root 3, root 6, root 9, root 20, 12. Are they follows an arithmetic progression? Take that A2 minus A1, that is root 6 minus root 3. What is the common factor you can take here? Root 3 common factor you can write. So root 2 minus 1. Next one, A3 minus A2 if you are taking root 9 minus root 6. Here also you can write root 3 outside. So you will get that root 3 minus what you are going to get root. Here A2 minus A1 not equal to A3 minus A2. That means it does not follow an arithmetic progression. So now we are seeing here that we have to take down that successive terms difference you have to take. So if it is getting an equal, so you can say that this is an arithmetic progression. Otherwise, it will not form an arithmetic progression. Now you can complete that exercise, all the sums in the notebook, exercise 5.1, because I have already explained all types of sum which is going to come in the examination. Okay, clear for you children? Thank you. Bye bye.